Hello students, welcome once again on my channel Physics Online Lectures. So for the today lectures, I am just going to discuss here nucleophysics and its scope. So let us discuss in detail here by this PowerPoint presentation here. So in one century, you can just say nucleophysics has found an incredible number of applications and connections with other fields, because nucleophysics has very much connection in other fields. So later we will see here. In the most narrow sense, you can just say it is only concerned with the boundary states of the proton and neutrons. So you can just say the main constituents are here. These are the protons and neutrons. And we know that from the beginning, when we have the study of the systems, was possible only because of the progress in the understanding of the other particles, like you just say here the electrons, positons, neutrinos, and other eventually you can just say quarks and gluons. So from the beginning, progress in this study has been developed as the elementary, as you can just say, like the particles, electron, positons, neutrinos has been discovered. So this is the very much important particles when we have a discussion about the nuclear physics. Now from here you can just have a complete theory of the physics, and this complete theory of the physics is also you can just element by the, as I have discussed here, by the discovery of elementary particles, then for the nuclei as such you can just say here. So student, in this we have just recent advances, you can just say with the development of the either you can just say with the discovery of the nuclear physics has been much more improved with the discovery of the particles, elementary particles, you generally say them. So as we have we are discussing here the nuclear physics. So nuclear species in the nuclear physics is determined or characterized by number of the protons, which are represented by this Z, and this have the number of neutrons. So number of protons, as usual, it is represented by Z, which is also set to the atomic number, and this is the number of the protons. I will discuss how we can just calculate number of the protons and the neutrons for a particular nuclear species. Now there are, you can just say, thousands of the combinations of these neutrons and protons, and they are sufficiently long-lived to be studied in the laboratory, as you can just say here. And the large number of the possible combinations of these proton and neutrons is to be compared with only 100 or so elements characterized simply by this Z here, which is the proton number of the protons. Now I will just show you in this PowerPoint presentation, I will just show you a map of the world of nuclei, you can just say, because there are so many elements which are existing in the periodic table. So I will just show you a map. You can just say it is exactly map, as you know, it is the you can just say it is all overall a description of the you can just say what are the things we are studying in a very simple and concise way. So map, as you know, Indian map, political maps, Indian map is also there. So we have the you can just say a miniature of all the particles or all the chemical elements. I will just show you, and in this you will just see here most nuclei are unstable in the sense that they are having the radioactive nature. That's why they are showing to be the radioactive nature. So let's see here. So this is the map, you can just see here, in which we have, you can just see here what is here. On x-axis we have the number of the neutrons, and on this y-axis, which is Z, you can just say this is the number of the protons. So students, this is N here and this one is the Z here. As you can just see here as we just, it is simply, you can just say N equals to Z line. This is simply N and Z line. As you just see here, for the elements to be stable meaning to say that those molecules are more stable which have the N upon Z ratio same. N upon Z ratio meaning to say that number of the neutrons is equals to the number of the protons, so they are more stable. Like you have generally 6C12 carbon. What is there? Number of the protons are 6. Similarly, number of the neutrons are 6. So 6C12. Similarly, 8 or 16. So generally you will just see here lighter nuclei are the more stable one. We will discuss it in later with the help of the binding energy, and with the help of the binding energy curve it will be much more clear to you of the discussion about the nuclear study, nuclear stability. So we will also discuss that one. So you can just see here, this is the particular graph or a map of this. You can just see here, we have here number of the neutrons, here number of the protons. Now you will just see a line which is just having some characteristics, as you can just see here. So what it represents, you will just see this region is approaching towards the isotopes. Isotopes meaning to say that same atomic number. And what are isobars? You will just see here this region. This is corresponding to the isobar. Isobars meaning to say that same. You can just say this corresponding to the same mass number. Similarly, we have isotones. Isotones means number of neutrons are going to be the same. So in this is the particular, you can just say figure corresponding to the particular corresponds to this isotope, isobars, and this is isotones. You just see here in this square with the black dot, you can just see here this corresponds to the half-life. Half-life, this is greater than 10 raised to power 8 years. Certain nuclei, they have the half-life, it is greater than 10 raised to power 8 years. And you will just see here, this is the square which corresponds to the beta decay. And you will also, you can just have this corresponds to the alpha decay, and you will just see here dot, it is corresponding to nuclear emission. You just see spontaneous fission, this is represented by the top. So this is the students, this is the proper descriptions of this particular map in which we are discussing isotopes, where we can just have the isotopes nature, when we have the isobars, and when we have the isotones. So generally with correspondingly alpha, beta, as well as corresponding to the nuclear emissions as well by this particular map or particular diagram in figure. We will discuss it as you can just see here. Generally, we have the mass number is represented by total number of the neutrons and the protons, and you two combinations such sufficiently long-lived to be naturally present on the earth of the significant quantities. You can just say number of the neutrons and the number of the protons. Now these nuclei are the black squares. You will just see here black squares. You can just see in this particular diagram. Black square corresponds to the this. There are certainly black square in figure we have just seen here, and define the bottom of the value of the stability in figure we have just shown this previous. So one important line of nuclear research is to create new nuclei, meaning to say that both high up on the side of the valley and especially super heavy nuclei beyond the heaviest, now known as this A for mass number is 292 and this proton number is 116. And phenomenological argument just suggests that there exists an island of the stability near where corresponding to Z, this is 114 and 126, with nuclei that may be sufficiently long-lived to have practical applications as well. So student, this is the corresponding, you can just say here, this corresponds to the particular diagram just I have just shown here. This is corresponding, total description is just for the explanation of this particular figure. Now this is I have just told you about the corresponding nature of this figure. So you can just see, as we just see here, because we are discussing here the scope and what are the scope in nuclear physics. So we will discuss here the physics of nuclei as such have been a very active domain of research, because you know there are so many researches ongoing process, and we have certainly some of more results are coming day by day with the help of this nuclear research. And for this we have to construct machines. Machines maybe as you say LSC, Large Hadron Colliders. What are there? Here they are just constructed man-made machines for the detection of the, for explaining the theory of the universe. You can just see here the physics of atomic nuclei is in itself a domain of fundamental research. You can just see here physics of atomic nuclei is the particular basic information. This is the fundamental research. It constitutes a truly many-body problem where the number of the constituents is too large for the exact computer calculations but too small for applying the method of the statistical physics. You can just see it. What happens in heavy ion collisions? One discovers subtle effects such as local superfluidity in the head-on collision for two heavy ions. You can just see what happens in the LSC. LSC में generally क्या है? Colliders are there, and with the they move at a very high speed, and the protons are going to be moved at very high speeds. So they are the collision, and we have certain you can just say here results which is totally based upon this total scenario is based upon these collisions. Nucleophysics also had an important byproduct in elementary particles, because physics and the discovery of the elementary constitutes of what is the basic construction of the matter, quarks and leptons and their interactions. So nucleophysics, you can just say we have an important byproduct in elementary particle physics की बात करते हैं, या discovery of the elementary constitution हम जब बात करते हैं कि what is the constitution of the matter, what is the quarks, what are the electrons, and what are their respective interactions. So this is totally, you can just say here, so total किस पर based है? ये totally based है nucleophysics की जब हम बात करते हैं तो totally elementary particle के physics के साथ साथ उसमें मैटर का कंस्ट्रक्शन कैसे है, मैटर कैसे कंस्टिट्यूट हुआ, या क्वार्क्स एंड इलेक्ट्रॉन्स कैसे जनरेट हुए, एंड उनके बीच में इंटरेक्शंस कैसे पॉसिबल है, ये भी हम इसमें डिस्कस करते हैं. सो यू कैन जस्ट सी हियर nuclear physics is essential for the understanding structure and the origin of the world in which we live, because we are living in the world where so many of the production hydrogen bomb is there. What is that? Nuclear fusion. You just see here large reactors are produced, means for the generation of electricity, that is nuclear fissions. Uranium, thorium, so many rich country, Australia, generally they have the thorium. Thorium, uranium, हम उनके पास बहुत ज्यादा है generally. And so what they are the, you can just say thorium rich country or uranium rich countries are so many here, and this is this type of the nuclear physics, you can just say it is for generation of the electricity is done with the help of the nuclear reactors. Are so many nuclear reactors are there, and you can just see here the birth of the nuclear astrophysics is a decisive step toward formation in the astronomy and in cosmology. Nuclear astrophysics, generally you see nuclear physics and nuclear astrophysics, जो किसके बारे में बता रहा है? Astronomy और cosmology जो involved है for the formation of the universe. And in addition, nuclear technology play an important in modern society as well. We have so many examples in modern society, you can just see. So you are also knowing some of the examples in modern society. So nuclear physics has a very much important and vital role in the day-to-day life as well as, and we are here have some elementary idea about what is the nuclear physics and what is the scope in nuclear physics. So student, I hope you have just learned a lot about this lecture, and we will just discuss it later on in detail. So this is the basic understanding of nuclear physics, and anyone who is interested on going in the research area. So nuclear physics has a tremendous, you can just say, door of the nuclear physics, or you can just say it just creates a door to the young researchers, and so they can just go in this particular field and they have a bright future. And because all around the world many of the research is going in the field of nuclear physics, so nuclear physics is very much important, because it is have a very, if you just study nuclear physics is so much full of curiosity. What is happening around us? So it is all about the basic understanding and basic the assumptions from which our day-to-day life or all of the origin of the world is based upon. So this is the proper understanding that you have to just study, and you can just have the proper knowledge of this particular subject that will be very beneficial for all of you. So student, thank you, thanks for watching, and we will meet in the next lecture with some more, you can just say, concept build up you can just make your concept. So student, thank you. Thanks for watching. Thanks to all of you. Subscribe to the channel and